instrumentation and signal and systems. And he has completed many projects like automatic vehicle washing system, electronic trolley corporation, weighing gate automation system, pick and place robot. Then he has research paper in reputed international journal and as well as reputed international conference and symposia. So welcome sir. He will deliver us about some lights on stochastic dynamical systems. Thank you.
Thank you. Good morning to all of you. Good morning. I think all of you will be from electrical, no? Basically. Any other branch? Only electrical. Okay, so this first word is stochastic. How many of you are aware of this? Stochastic, because from that we have to start. Then systems and all things are there. If you are new to that, my session will be interactive, because if I deliver on the basis of all equations and what is stochasticity and all that, you will get bored. So instead of that, we will have some learning. So basic things you should know. For that I am asking, if you don't know anything about stochastic, then we will start with stochastic. That will be simple. You have to gain something from my talk. That is my aim. Otherwise, I am having advanced topics also, but I am just asking you whether you are aware of that. It is new to all of you, stochastic. Okay, so we'll start basic. What is signals? Behind this last word, systems. What is signal? Anyone? What is signal? When we are calling as a signal, what it does? So signal means we are normally electrical signal, light signal, any signal. What is it?
It's some information, sample of information.
Sample. Then any
Communication between two receiver and
from
transmitter.
transmitter to receiver. That is also one signal. It transmits the signal. Then
Instruction to do work and work.
yes, instruction to do some work. Normally now IT world is there, so instructions, programming, all things are there. But analog and digital are also there. Analog signals were there. Discrete signals are there. Continuous signals are there. Signal is nothing but it is a physical phenomena which drives something. In case you have instructed me to deliver this lecture, this is signal given to me and I am executing that. That is also signal. So there are variety of, just I discussed, analog signal, digital signal, continuous, discrete. Then nowadays we are converting any analog into digital, and then data is collected, and on the basis of data many analysis is done, statistical is there, everything is there. And what is system? It is combination of physical components. Suppose electrical motor is there, it is combination of all rotor and stator and everything. Electrical signal drives that things and get the output. You are getting that speed of rotor, and if load is connected, then we are getting the result. Same thing with any, this is classroom suppose. Students are system, combination of all students. Some lecturer is coming, they are driving this 60 students or 40 students, and after that lecture they are going away. So this system is driven by their lecture, and output is what? Gaining that knowledge of that particular subject. That is also system. So it is a physical combination or a combination of physical components. So signals and system, you are aware of that. Everything comes around these two words. Now up to graduation level you might have only one subject, I think, control system or digital control. In masters it is digital control is there, or some other names will be there, but not more than that. So whenever we are opening book, always it has been taught in, I think, in all syllabus apart from research, that every system is linear time invariant system. Have you heard this? When linearity is there, time invariance is there, and system is there. What happens? Everything then you can get the Laplace transform, you can get mathematical model, and after getting mathematical model you can do the programming in MATLAB and all that software, so that system can be characterized or analyzed. Now you tell me, in physical or in practical, systems are linear only? Any system, you take example where non-linearity is taught to us. I am 2001 batch pass out graduate, so I know linearity was there throughout the 4 years in graduation and post graduation also. Very small topic was on there, non-linearity. If practically everything is non-linear, is it? You check fan speed or this output of tube light, output of AC, everything is, maximum things are non-linear in nature. Then also for mathematical simplification we are considering all things are constant and we are taking system at rest and we are solving with the mathematics. Because in India maximum, I am not claiming that, but maximum critical mathematics is avoided. When we are going to learn mathematics, because of don't know the methodology, or some are there, some good teachers are there, but everywhere we are going away from mathematics and we are taking simplest form. And that simplest form, again while designing, you might be a syllabus designer, maybe in big positions, to have that simple syllabus. Again we are adding simple topics in our subjects to avoid the mathematics. First order differential, second order integration. So due to that, what has happened? We have gone away from the reality, and that's why when our students are going in industry, maximum time the practical problems they are facing, that is not getting covered in theory. Our college or this system. It is everywhere. Very few colleges are there. They are taking care. Very few. Our aim in this, if system is non-linear, time varied, means if any differential equation you have to solve, linear differential equation LD, you will get the answers. Y is equal to something by applying various methods. But if it is non-linearity is there, time variance is there, if there is no closed form solutions available, then what to do? Whether to leave that problem and run away from that. So it is the case, we are not touching that. We are assuming all constants. Suppose one equation is there. A system is basically related to many inputs. MIMO systems are there and SISO systems are there. Single input, single output system. Multiple input, multiple output system. If we have to analyze, then we are keeping all other things constant and we are taking one to one. And in that also we are considering linearity. So we are getting simplest way to solve. But when we are taking that in hardware is highly, what you can say, it will get disturbed by the surroundings. Surrounding means hardware, it contains diode, transistors, MOSFETs, and anything. If it is getting disturbed by the other disturbances, like temperature is there, surrounding temperature. Suppose we are working here in 30 degree, and if we are operating that same circuit in Himalaya, so definitely that effect is there on the output. So if we are not considering that parameter on the performance, for example, ECG machine is there. ECG machine is very sensitive and it is related to lifeline of any person. Suppose in that electronic components are there. If that are getting disturbed by the external disturbances and we allow to disturb that system, that may give the wrong prediction or analysis of the output. In that case, that is very dangerous because that is related to life. So in such cases, we should include all the disturbances while analyze the system. So there is word comes. Randomness. Might be you have heard. Everything is random. Now, I think our this talk was at 9:30, but I didn't come at 9:30. So it is random. At what time it will start? You were aware of that? The standard was 9:30, but I may come early or after this. This is randomness. Everything. If you take AC, fan, tube light, output, anything, it is random. I should start from this onward, but I have taken feedback, so I started from basic. So this is also randomness. You were not aware of that, sir will tell you something about signals and systems and basic thing. So when randomness comes in picture, and if we account that randomness, then that goes in statistics, in continuous time system and discrete time system. So continuous is related to stochastic and statistics is related to discrete, and probability comes in picture, because when no closed form solution is available for your equations, you have to find something close to that, and how you will find? By applying various techniques. Now we'll see one by one. Hope so you are now up to stochastic word. I will explain you how the stochasticity is there, how normal system and this stochastic dynamical systems are. Any doubt up to this? Just basic, you can ask. So it should be interactive, it should not be one-way communication. So if you want, I am basically instrumentation and control system person. I am not a power system person. These are from power, I think maximum will be from power, na? Can take power. Or someone is there from control. Can take, okay. Your graduation is from electrical, na? Or
Instrumentation.
where from?
Any college of engineering.
Okay, so you are aware of signals and system, digital control and all that. So it is related. One cannot avoid signals. One cannot avoid this nonlinearity, time variance. We have to, as an engineer, we have to apply that. And what is the use of this analysis? If you are, suppose, if you are designing a motor or anything, before going for actual design, you have to obtain mathematical model of the system based on your parameters. And once a mathematical model is obtained, you are giving some virtual signals, step signal, ramp, and all that. Based on that performance output, you are saying this system will work correctly as per this model, and then you are converting that mathematical model into hardware, and then actual motor is manufactured with that specification. Now if you don't analyze with nonlinearity, what will happen? If you take only good things, the model will be wrong, and when that motor will get manufactured in actual, that will give wrong. That may give wrong. This is one example. I am taking motor because all of you are familiar with this one. So if ECG system is there, a biomedical system is there, analytical systems are there, many systems are there. So that is important to consider disturbances occurring in the system. And when disturbances are there that are random, disturbances will not come that I am coming, so please include me in your analysis. They will not say, because that is random. Many types are there. Okay? Hope so you have got the basic fundamentals behind this. Now we will move towards these are some basics I am going to talk, but from your background, I will take main points only. I will not go in mathematics in details. This is the stochastic system definition by books or references. This stochastic differential system is dynamical system subject to effects of randomness or noise signal. Such effects of fluctuations have of practical interest over century that we have discussed. One. Now there is a difference between noise signal and signal. What is that? When you can call noise, any signal as a noise? Unwanted signal. Then adding disturbances. So for that we are using filters. Digital signal processing is there, isn't it? So that, but before what is happening practically, we are designing system, and after system is getting disturbed by the external disturbances, then we are doing something to filter out that. After getting that effect of disturbances in the system, then we are filtering out that. If we take care of disturbances in advance, and if we do some provision in the system only with the physical component, then the output may come to the more accuracy. Instead of having, you might have heard feedback control system and feed forward control system. Feedback is what? Some disturbances affecting on your process, and then output is measured. It is not as per the design, then we are again correcting the error, and that is getting in loop. So that is, but every time what is happening, that motor or something end device, that whatever maybe motors or controllers are end devices are there, that will get reflected or that will deviate. Due to that, there may be problems on the hardware at the end. If continuously it is changing. But if you take care of all disturbances coming in the system while designing only, what will happen? Maximum errors or disturbances will be tackled. Are you getting this? So in this case, instead of having that filtration after getting the output or getting disturbed, we are taking care in advance. So this noise signal is nothing but a random signal. Yes, fluctuation or randomness are classically referred as a noisy, random, or stochastic when they are suspected origin implicates the action of very large number of variables. Now these are the some applications where they are important. Now here you will find why this has not been popular. Might be you are hearing this stochastic word first time. How many of you are there? They are just hearing this word first time. That stochastic systems are also there because you are from teaching community, na? All maximum or industry people are there. Okay, maximum. So the pricing in finance. Other than that, all are technical, maximum technical things are there. Astronomy is there, satellite is there, air quality, seismology, helicopter rotor, this thing. When anything related to finance comes, the person or human first attempt that or get attracted towards finance. We are also there. We are also human beings. So we are getting attracted. So first time when there was fluctuation in stock market. So for predicting what will be the situation of Tata Power suppose or Tata shares in 5 years, depend on the previous fluctuations, one can estimate or predict this share will go to this and this value from 900 to 1100 or 9000 or whatever. So again there is statistics, there is probability, everything comes in along with this noise. And fluctuations are what? The variation around the, suppose policies are getting changed in India, or the industry related things are getting changed, or leadership in Tata is getting changed. These are all dynamical things which are disturbing the share market prices. Are they right? So first time this stochasticity was tackled, or it was solved by Black-Scholes equation. Black-Scholes equation, and that got Nobel Prize. That equation is very popular to solve or to predict the share market prices, and that was analyzed by Black-Scholes and that. But same thing was not in technology because it involves very critical signals, but we have avoided that from many years. And foreign people has attempted from that non-unity, randomness, noisy signals from first day only. Because in their syllabus, they are free to teach anything. They, on the first day only, they will say everything is non-linear. So try to solve. At least they are getting knowledge of basic things, and we have ran away from them. Still, hardly on if you count, so I don't know, 20 or 30 people are doing research on this randomness or in India. If you take electrical community, when we were attending the conferences, very less people were there. And then in actual industry, people were working on noise. You take example, today also we are coming by car to office. When high voltage lines are there, our FM radio is also getting disturbed today also. Despite of many electronic engineers produced by India, they are going away abroad. Then also we are unable to solve this problem. Today also. Have you observed this?
Yeah.
Still there is noisy. When high voltage line we are crossing, FM output is getting disturbed. Why it is so? We have not taken care of high voltage electromagnetic interference. While designing the radio system, MOSFET based, I am going to cover one small topic in that. One of the paper was written on that MOSFET gate signal disturbance. So that challenge you have to take. And industry wants what? How you are helping them to solve their problems. Here in teaching faculty, you just have to complete syllabus and all that thing, and our salary is getting deposited every month. But when students are going, they are industry is checking whether this person is helpful or not. Isn't it? Randomness. So we have discussed diagram. I will give you some picture here. This is deterministic signal. This is stochastic signal. Now, if you observe, deterministic means what? We can take some samples. We can determine something for that, or you can write something as a ramp signal, as a step signal, or something, or which can be easily written in mathematical form. That is deterministic. And when it is come in the right side, it is random, stochastic signal. One cannot determine this. You check, just it is a noisy signal. Okay. Now on that deterministic signal, you can apply easily that differentiation, integration. If it is discrete, then it is probability distribution things. If you take stochastic, then they require Ito differentiation, Ito integration, then stochastic process with measure and is probability array. Some different. Now what is this Ito? Then one more word will come, Statovich, Markov, Kolmogorov. Many scientists are there. They have attempted, but no one is from India. Ito is Japanese scientist. This is stochastic process. Just in mathematics form, we are having two variables. At a time, you check t, comma, omega 1. Same omega 2, omega 3. It is with respect to time, but it is with different noise signals. Okay, these are the processes. And one can analyze on that particular time what is the status of this. Various outputs will come, and on the time sections we will get this y1 and y2. Random variables. Now, if you check one book, random probability, random variables, populous. In that you will find all this. That is basic book behind going in this particular subject. It is a basic in probability. This is the historical development
importance of randomness first. Introduction of concept of Brownian motion, named after biologist Robert Brown. In 1820, he noticed motion in tiny particles suspended within the medium of living pollen flakes. I will give you a simple example of this. In night, you will have street light is there, that is focused in some shape, but you will see some small these particles will move. Whether that particle movements is linear or it is in particular format, it will go straight or like that. It is random. You will see easily you can visualize. Same fundamental he has also. So you will find that one particle will have its travel path as a random. It may turn right, it may get down, it may go up like that. Where it will go, we don't know. So that is basic behind this Brownian motion. Then Albert Einstein, he worked in 1905, worked on Brownian motion. This was just observation that he gave that motion is random and that is called as a Brownian motion. Because something should be there and on that next one will start. So Albert Einstein in 1905 worked on this Brownian motion as part of his kinetic theory and also on transitional probability density light theory. All of you are aware of this Einstein theory. Then Norbert Wiener put Brownian motion on a firm mathematical footing with the Wiener process. Again, he gave some confirmation about that Brownian motion and again the name was given after him, Wiener process. A.N. Kolmogorov in 1940, founder of modern noisy dynamical system along with probability theory and turbulence theory. He is very great person or scientist who has worked a lot. He is Russian and Kolmogorov theory is there. If you Google out, you will get all things. Then main breakthrough was Kyosho Ito. He is Japanese. In 1954, he developed Ito stochastic calculus. Till this Ito, they have done analysis or they have developed mathematical model for that Brownian motion, randomness, noisy. They have applied that somewhere. But theory to solve such randomness, just like linear differential equations are there, usually you can solve by Laplace or any integration and all that. But if it is random differential equation or stochastic differential equation, SDE or RDE, then what should be the basic? There should be some format or laws or rules. With the help of that, one can solve the random differential equation. So Ito was first person who has developed that stochastic. We are going to cover that. So Ito was the first person. So after his name, Ito stochastic calculus was given. Name was Ito stochastic calculus. Normal calculus and this, it is different. Normal is for linear and all that we have discussed. This is for randomness. Then Hida is there. H.J. Kushner, he used that solutions for developing filtering, non-linear filtering, stochastic stability and then. Once you get solution, what you will go for? You will go for applying that. So filtering, after getting knowledge of noise, you can remove it. And then next is prediction, estimation, all things comes in picture. He has H.J. Kushner is a famous author or scientist who has developed related to this filtering. Then again, if signal is coming, but how much stable that signal is or output is, that is important. So stability is also there. Then these are next scientists. They have Albert Shirov, Robert Klister. Then Hudson Parthasarathy developed the quantum stochastic calculus. Nowadays are of quantum. And Hudson Parthasarathy, T.R. Parthasarathy is great scientist from India who has first attempted that things in India. You can say pioneer of that. Then that shows Martin we have discussed winner of the Nobel Prize in 97 for the black and shows Merton model for option pricing using stochastic calculus. This is the historical development. This is mathematical things, but I will take some picture how it is. HD is getting developed, like linear differential equation, how SD is formed. Brownian motion is the the base. Then stochastic calculus. Then Stratnovic calculus. Stratnovic is just, he has developed some different calculus than Ito. Maximum things are same, but some formulas are, the table is different. And then last is stochastic differential equation. For solving this SDE, we can use Ito or Stratnovic. That is available methods. That was the first Brownian motion of milk globules in water seen under Robert Brown's microscopes. That is moving. So in any case you can observe that. I will give an example of that light. This is some again mathematical. Brownian motion is the unique process with the following properties. No memory, means nothing is stored in that. So if you take first BT1 minus BT, means next difference with previous one, next with the previous one. So they are independent. That small distances you can check BT1, BT0. That is Brownian motion. Then invariance. The distribution depends on time t. How much distribution depends on that gap time t. And continuity. These are the properties of Brownian motion. It is very important. B0, Brownian motion initial point is 0. Then expected value of Brownian motion is 0. Variance of Brownian motion is t. This is the base for solving that particular equations. Now Brownian motion belongs to several families of well understood stochastic process. You have heard Markov process, particles. Gaussian process is very famous. Have you heard Gaussian process? In probability theory you might have heard this. Then Levy process. It is now Ito stochastic calculus. The rules for stochastic calculus are different. As I said, if you take integration of t over dt, then it is t square by 2. But if you take bt or dbt, it's with reference to Brownian motion. Because what is base for our stochastic calculus? That Brownian motion. Brownian motion is related to randomness of anything. We have to take anything with respect to Brownian motion. So that is bt square by 2 minus half. This is correction term added by Kyosu Ito, and this is the proof, or based on that the stochastic differential equation is formed. If you take derivative of any process x1, then that is function of t comma xt, and then that is rearranged. If you take f, this g of t is added, then dst by dt comes in f txt gtxt, and it is getting multiplied with noise. Noise comes in picture. When noise comes in picture, no one can apply conventional calculus. Our pen stops there. Any mathematician, those are interested, they are going, but everyone stops here only. And after getting this noise, it is getting multiplied. That is we are mentioning that with Wt. Now once that dt is on the right side, so it is getting this form dxt is equal to function of txt gt. These are the f and g are the coefficient. We are having function of this. G is also function, but notation is given different. White noise, that is Wt, it is derivative of Brownian motion. Derivative of Brownian process. dBt by dt, that is white noise. And where the Bt is Brownian motion process. So dBt by dt is getting replaced by Wt, and if you replace that Wt white noise by dBt forms, then it is called as a dBt. What we have done? We have added white noise. You are aware of white color and color. White is with same, that is having only one ray, white. Others are with different colors. They are having other things. Okay.
Why two functions are there when you take that differentiation?
One is, just see, there is function. We have to take something which is attracted by noise. This is the linear thing. This is one of the parameter which is linearly dependent. This relation is linear. But if you have to add something non-linear or noisy, where noise will come? If this comes, then this is 0. Again directly it will be, but some component will be without noise and some will be with noise. And to have combination of both, we are having this second function where noise is getting related. All of you getting? Here noise comes in picture. So noise is, we are considering white noise with single frequency, you can say. For example, if we are taking wavelength, then it is a single. Is it clear? Many times it comes 0 also, first function, because there is no only noisy signals are there, only noise is there. So white noise is derivative of that Brownian process, and that gets reverse form. We are adjusting that dt on the right side. So Wt dt is replaced by dBt. Here Wt dt, here it is Wt dt. That is getting replaced by dBt. Because of this, if you take dBt is equal to Wt dt, and dot is just for differentiation. So Bt dot, or having simplification, Bt dot is nothing but derivative. So that gets the form of stochastic differential equation. dxt is equal to f dxt dt, then gtxt bt dot. Ito integral form, if you take integration of differential form, what will happen? It will come in integration. Integration of this equation, stochastic differential equation, with the help of Ito stochastic calculus. It takes form xt is equal to, this is initial, again integration of that, and here dbs comes, because we are taking inverse with s operator. So that you will see this is in double denoted, it is Ito integral. Okay, that comes in picture. Now for solving that, Ito calculus helps us, and then multidimensional formula where more than one inputs are there. Summation, it comes in discrete form. What is Ito's basic rule? Ito derived that this is multiplication sign. If we multiply dBt by dBt, then it comes dt. This is groundbreaking innovation. So dBt multiplication comes dt, and anything multiplied with dBt is 0. dt also 0. This is famous Ito table for solving that particular Ito differential equation calculus. Because of this dBt comes dt, solution comes, or closed form solutions are possible. And then we are getting that equations, those are closer to our actual ones. We cannot say that is perfect, but at least it is better to consider these noisy signals instead of not considering them. It will give some randomness effect or various parameters effect on the system. Now this is Ito calculus, this Kyosho Ito has become a key tool in areas such as biology, economics, finance. White noise process approximates a physical process. Then zero mean exponentially correlated stationary process called as a colored noise can be generated by linear stochastic differential equation caused by white noise. Again, white noise will generate the colored noise with the different wavelengths. In practical, we are calling that. Just prism is there. On one side, prism, one ray is doing, and then you are getting spectrum. Then this is white noise, Brownian process for color noise. Then again one more scientist, this is Stratnovich. Like at Ito, he has developed something different, and that is proposes new symmetric definition of stochastic integral. The Stratnovich integral is defined for a much more restricted class of functions than Ito integral. Here evaluation again small change is there. You will find Bt minus Ba is there. Again small integral. He has considered that. So it can in fact be shown that Stratnovich integral and the differential that defines satisfy all the formal rules of calculus, including integration by parts, variable substitution, the chain rule of differentiation, so on. When anyone is developing calculus, they should satisfy. That is, both are satisfying the conventional calculus rules. After defining two different stochastic integrals, which one is better or which is right or wrong? Both are having their own merits and demerits. So some have attempted ecocalculus solutions, some have attempted Stochastic. I will skip, this is more mathematical, so because if just this master equation, keep in mind, master equation is there, which can be defined evolution of conditional probability density for given initial states for process satisfying
Sir,
HT.
you can continue with this because I have given them one article discussion paper
Okay,
of Sharma Patil theory.
they are aware of it. But you tell me, because we were also new that time when we were in PhD. Sharma sir is my guide. I was second student, then he comes, and then more students are there. So if you go through paper in one reading, two reading, three reading, four reading, five reading, whether you are getting something, frankly speaking, it is very difficult. Again, because when you will get satisfied, when left hand side will come to right hand side, then only someone will rely on you or they will keep faith on you. Something if you prove that left hand side is equal to right hand side, then people will salute you. Otherwise, anything what I am talking, no one will believe you. Because everything should be in mathematics. And our Sharma sir, his guide was Parthasarthi sir. So
K.R.
that is
Parthasarthi.
K.R. Parthasarthi. He used to sit with him
Recently,
to solve
he has passed out.
at 99 something. 99 or what was the age of Parthasarthi sir?
91,
91, 92. So he was a great statistician. He has solved many problems. He was
And his
professor
supervisor was this
Hudson.
Kolmogorov.
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 External this supervisor. Kolmogorov. So that linkage is there. If you have published papers, one thing is there. You always search for Einstein number. What is your Einstein number? Do you know this? What is your Kolmogorov number? For example, we are taking that. Or what is your Einstein number? What is your Newton number? Are you aware of this? Many of senior people knowing this. What is that? If Dr. Ravish and me are working together for publishing one, then Dr. Ravish and Dr. Sharma sir has contributed jointly. Then Sharma sir and Parthasarthi has done something jointly. Then Parthasarthi and Hudson has done something. Hudson and Kolmogorov has done. So how much that generations are there? Suppose 7 number is there. Then my Kolmogorov number is 7. So in research community, if your Einstein number, Newton number, what is your number? That is proud feeling for us. So that's why the Kolmogorov, they are coming in that generations because less people are going in this direction of research. So this is master equation. All I will skip that still because you will get bored. We will have some, instead of mathematics, we will go for practical things. These are the solutions. Here, one important is that stochastic systems can be put into three categories: linear stochastic systems, then bilinear stochastic systems, and third is non-linear stochastic systems. So randomness with this. Important is bilinear. It is yet linear but non-linear. It will have some linearity, some non-linearity. That comes in bilinear. My one of the main paper was with the binarity also. These bilinear systems are nearly linear system yet non-linear systems. In case the input to binary system is stochastic or random process, the system is said to be bilinear stochastic systems. Now these are the regular things which you have heard in control system. Now application of this Volta system, sampling mixer, register RL circuit, helicopter rotor dynamics. We'll discuss these examples in details because you are familiar to these words. So application of this to these circuits, I have attempted 1-2 years attempted me
Okay.
of our because sir used to give that one problem to one student because one problem is 1 year. So it is very difficult in that case. Proofs are there. This is in my published paper, so it is available. I'll give you if anyone is interested. This is, we'll go in details of this. You have seen normal RL circuit, resistor and inductor circuit. This is very basic and there is some DC supply is given. Now how to apply that bilinear systems in this one? Bilinear stochastic system model for RL circuit with noise in source voltage. This is the external. Battery is attached or power supply is attached, DC power supply. And if some noise comes in the source, what happens and how to analyze that mathematically? This is the problem. Okay, and resistor. We are always saying resistor is having tolerance factor. Resistor value if you measure with multimeter, never if it is 1k ohm resistor, it will never show you 1k, 1000 ohm. It will be 998 or 997 or sometime depending on the characteristics it will be 1001 or like that. So we are seeing plus minus 2% tolerance also. If resistor is showing that what you can say randomness itself, and if we are designing something with 1k value in mathematics, and if it is exhibiting or giving that randomness of 2 ohms, whether that circuit will be giving correct output? If you go in micro level, and if that 2 ohm will have some impact on the output in biomedical systems, mainly where the small things are important in medical systems, CT, MRI, then any system where the resistors are there. So we have to take care of the randomness inside that resistors also. So that we have considered as an internal noise, and one is that source, because source is again it is getting fluctuated depend on the circuit. We are not using very high and sophisticated sources. What will maybe our lab sources are there. If battery is also there, same there is disturbance of the noise. So same thing, we have added this sigma s and sigma r. This is coefficient for that noise strength you can say, and zeta 1, zeta 2. This is added in r plus this. This is the variation. Okay, Vt plus this. Now our simple Vt will get modified as Vt, that source is source noise is added, sigma s zeta 2 is Vt I sigma, just see in bracket r is replaced by this variation, r plus sigma r zeta 1t plus L divided by t. Inductor is not, we are considering L because at a time we cannot take noise in all components. Again that will again run away from this also. We have to take first any noise in resistor, then second by keeping resistor constant we can go for inductor noise, depend on that. So we are considering there is no noise, so L is pure. So we are rearranging this equation to form in standard, that is stochastic, stochastic differential equation. What we have done, we can easily identify that it is rearranged to get DIT. Now here process variable is IT, so DIT is equal to this form is coming, and if we take simple reverse of this, you will see this is dB1 because two noises are there, two white noises are there because one is external, one is internal. Sigma that we have shown, sigma r and sigma 2, that are strength, and that is getting converted into dB1 and dB2. Is it clear? Now we are applying that calculus. If you take integration of that, then there is big proof in Google. You can get that. We will solve this by when dbt comes together, solution gets open. It is dt. And then if once we get dt, we can apply our conventional calculus, conventional differential equation, integration, all that. So that is important. Now after getting this, what is closed form solution? Once you get, but it is not final, still db tau is there, something is there, okay, because that parameter will remain same. Then we have to take mean in itosense and variance, and once you get mean and variance, that is this approximate mean, variance, what is the mean? In this case we have solved that circle was for Stachnovis and without circle was our convention. So in these two cases we applied that, and in itosense this was expected value of IT, expected mean value. Expected means mean value. This is our mean value. This is coefficient of that or intensity of noise. If you do mathematical analysis in MATLAB, all of you are familiar of MATLAB, we can easily change how much noise is sensitive. Suppose you take 0.1, then what is the output? What will be the current expected value? Then if it is 1, 10, 100, so one can determine that the noise intensity will have effect on the output in this regard. So if it is 1, if it is 100, if it is 1000, how the system is getting disturbed. It is not possible in our conventional thing. And other standard things are okay. L is standard, R we have taken. If you check, these are all conventional formula you will get in our normal LDE. If you apply Laplace transform to RL circuit, you will get inverse Laplace, you will get the solution for differential equations. Now in Stachnosis sense it is somewhat different, and variance is difference of these two. So what is importance of this? Now next time what we will do, we will keep R constant. We will go for L. L will have some noisy behavior. This is very small circuit we have taken because we are not, means we also still, we cannot attempt big circuits like your drives or motors or that controllers, because many parameters are there. But still, if we have something base, we can go for one step next. If you add two resistors, if you add one more, suppose capacitor or some more, color noise may come instead of single. This white noise, color noise may come. And this paper was published in this ISCI International Symposium in Japan. It is also in Google also on the theory of time varying binary Stachnosis stochastic differential system and its application. Any doubt or curiosity is there on this circuit? This was my first attempt to solve something. When I entered in research, PhD, I was not able to pronounce stochastic correctly also. So like you only. So from that we came to this first, and from this I applied that or used this equation in MATLAB. Then MATLAB is having all this, you can say, toolbox. You can easily generate random signal. That random signal along with intensity is given to system, and that was simulated. So this is analysis of RL circuit. Then another example of this is electronic half wave rectifier, famous. Again we have considered here. This is simple half wave diode circuit with one diode name is there, silicon diode, PN junction diode. This is conventional. Then again, when any parameter exhibits
people are not aware of that. So one can easily do some research. This formulation is important. We took 5 years, 4 years for understanding these basics.
Still we are in the
I
same.
mean the same. It is not, at least that into calculus, basic things. Now that has been converted into here. If you check, let us consider some randomness in the register R of half wave rectifier, and noise is due to thermal fluctuation in the resistance. As we discussed, there is some temperature change, then the value of resistor will get changed, resistance will get changed. Here 1 upon R is replaced by G, conductivity. So to have some simplification, instead of writing 1 by R many times, we are using G. And here that comes in the form of dVc. By rearranging this equation, this is the coefficient of noise, zeta R GTT. When GTT dt is getting multiplied, then that will get replaced by dVt. Here it is rearranged and it is taken in the form of bilinear stochastic differential equation. Again, applying in this case we are also to Stacknovich sense, that half factor is added, that is Stacknovich correction term, lambda 1 plus gamma t square by 2, and this circle comes, then this is Stacknovich. This. Without that, it is normally calculus. Then for avoiding complexity in notations, we have given that another notations for writing that, and then by using the closed form solutions. Closed form solution is conventional. Once you get dVt it becomes dt, and you can apply. And taking original notations and taking integration, this Vc equation comes. Current flowing through the diode as a constant. Again, I am saying, at a time you cannot take many noises signal together. We have to consider one by one, and then all together you can analyze the system. This is the output. Again, mean and variance is taken. Same variance, that expected value of Vc, that is nothing but mean. After achieving this, noise analysis of binary SD, question comes how to do noise analysis of nonlinear stochastic system with high order nonlinear. In order to answer this question, this is again Stacknovich. By adding this correction term, many problems were solved. But still people believing that Stacknovich is for again simplification and Ito is for basics, like that. Different variations are there. If I believe in Dr. Sharma, I will go through Dr. Sharma. If he is having more faith on Ito calculus, we will go in that direction. Likewise, there is variety in research world also. Then noise analysis of nonlinear stochastic system. Again, just like our nonlinear differential equation, nonlinear stochastic systems, we have to consider all angles with the simple circuit. All angles, linearity, nonlinearity, deterministic, everything. So this is a famous paper, nonlinearity and stochasticity by Mumford. I will explain that with the example. Here, the most important circuit part, as we discussed, then radio frequency receiver. All of you are aware of MOSFET receiver. Have you heard that radio is that is receiver? It catches the RF signal and then it converts into audio. And one of the part is this is RF receiver. That is one of the important block is sampling mixer. I will show you the block diagram. It is best example of that nonlinear stochastic differential equation system. It is desirable to perform front-end operations like mixing and analog to digital conversion, ideally on the RF signal, because RF signal, radio frequency signals are coming, that is mixed and then it is converted into digital one. The universality of sampling mixer, that is non-trivial electronic dynamic circuit, can be found in interconnected system, aerospace, wireless communication and all. In digital wireless communication technology, the sampling mixer coupled with A to B converter
answers performance. That you learn paper that I have taken, and based on this, he has drawn some conclusion, and based on that, as Chinese people are having more sophisticated instrument to analyze noise, but in India, I have checked very few IITs, one or two IITs are having that much bandwidth to analyze noise on screen. Still, we don't have that particular noise analyzer in India. So they are having that instruments, sophisticated instrument. They have done some practical work also, but in India we don't have that. So we were limited to do only theoretical or modeling part only. See, this is a simple circuit. This is source voltage and gate signal. This is a square signal. Gate signal VST and output VDT. So what do we consider? This is one of the first circuit on the RF receiver. Antenna is there, it receives the signal, it mixes the signal, and then all of you have heard modulation, demodulation, strong and weak signals. If weak signal is there, that is modulated to transmit over long FM and AM, that is same. FM is limited to small range and AM are over, that is long range. And in that case, one of the circuit is this one. So this is mixing mode and not non-mixing modes are there. This is simple working of that particular mixer in conventional. If there is some variation at the gate voltage, like what is gate voltage? That is the square wave we are giving or square signal we are giving, some 0 to 5 volts suppose, 0 to 2 volts, 0 to depend on the circuit. And if due to battery temperature or battery variation in car or anywhere that getting disturbed, then how the output will get changed, that we have analyzed mathematically. Are you getting what is the aim or objective behind doing this analysis was that if some noise comes in or the randomness comes in gate voltage, how the output will get disturbed. That was our motto or objective. This is the conventional. If you go in that sampling mixer, conventional output differential equation, these are the notations, and then we added. I am avoiding that mathematical notation to not to bore you, or if you go in depth again, we will lose interest in this topic. So this accounting the noise contribution to the gate terminal, that GT was there, gate terminal voltage. So we are replace that deterministic gate terminal voltage. We are getting with noisy signals, and that equation again comes with the intensity. Here we intend to answer two questions: is it worthwhile to account non-unity in the noise analysis of dynamic, and Stochastic method will lead to better estimation over the Ito's calculus. And then we studied that Ito-Stratowicz dilemma, and by adopting Stratowicz calculus, we have arrived this. That circle you will find, that is Stratowicz. And what is the advantage and disadvantage of Ito and Stratowicz? That we have compared in this one. And this paper was published in Journal of Franklin Institute. Since the closed form solution to nonlinear stochastic differential system is not possible, no one can claim that this is the closed form or firm solution. We are going towards approximation. So we introduce the notion of evolution equation. Evolution equation means what? Depend on that some parameter it will get evolved. It is not constant. It will get evolved. That many forms will come. Small changes will occur, and many forms will come. So first we derive the exact conditional moment in evolution. There is book evolution equation. In that I think sir has written that evolution equation book also. Same. Again based on dynamic and numerical solution to exact conditional moment are not possible. Again I am saying we are not claiming that these are the perfect, but we are going towards that approximation, which will help us to remove noise perfectly or nearer to the values. Again, this is how to solve that. Mathematically, we have solved this. Ito and Stratmo is both. Here, this was the base paper. U and Lum, they have obtained this equation, and then based on that, in this Journal of Franklin Institute in 2015, our paper was published on nonlinear stochastic dynamics circuit using static differential. Here we have compared. I will show you graphs so that how we were better. These were some values we have taken for some simulation purpose. That source signal 5 sin omega t. This is 2 pi radians. Some values. Source signal frequency 30 kilohertz. Then gate terminal 5 volt peak to peak. Because some parameters should be decided, and then we can analyze the randomness. So, and these values are taken from the reference paper that you will learn. We will say that this dot dot is the state trajectory of proposed model. State trajectory means again the output trajectory, how it is getting changed. The unperturbed trajectory of drain voltage means without noise. Unperturbed, that is not perturbation, is also disturbance. Perturb means getting disturbed. Unperturbed means without noise, this noise. Then U-Learn model state trajectory. So it is ours and it is U-Learn model. You will see there is very close variation of ours with that, and that if you check with U-Learn, that is very away from. If you check the differentiation, you see this gap. So we are trying in some, again it comes which part you are taking for analysis, where it is getting more disturbed or it will have more impact, because we can take sections in which part it will have more effect or noise will disturb the system in a larger way, and in which area it will have smaller effect. That we can conclude from this analysis. Then this is same with the mean and variance. You see mean trajectory, uninterrupted, then ours and U and Lung model. There is more variation of that U and Lung model than ours. So we are closer to the ideal one through this Stratmovich integral. And these results are with U and Lung paper, and ours results are there. So we compared that, because in research domain you have to show something. Just before starting our talk, I said that left hand side should be equal to right hand side. Then only people will recognize. So if we compare that with the past researchers' results and how we are doing better than, or how we have achieved better, then they will accept your papers. Otherwise, no one will do. And they want how you came to this picture. It is not just a graph. They want mathematics behind that. And for mathematics, a lot of papers we have wasted. Because it is notation. Again, your eyes should be very much concentrated on that notation instead of zeta dt. So every time we were very much conscious that no notation should be wrong while doing this solving on paper. Then we can go for mathematical simulation in MATLAB or any other software. So it was very useful result that time. And what is next? It is not so that we should stop by showing these two people. What people will say that these are only theoretical scientists. Even more people, because if practically something change is shown, people will clap more. If we are showing this, then what is different than that? Because it is not visible. I have not shown you the change in radio signal practically. What is limitation for applying these theoretical results or simulation in practical? We don't have that much bandwidth which will go till depth of this. Okay, and in China they are having very good number of that particular instruments. They can analyze that, they can show that. That's why Chinese people result are, you cannot say they are doing copy paste, isn't it? Because they are using, they are doing practicals and doing and then showing that too, and that's why the systems now they are coming with many systems that are far better than US also. So my aim to say is that we should go next steps forward to this one. In any case, in your case also, your research topic also, then this is variance model. How variance? In our case, variance is very less. In their case, variance was very large. The variance term, mean and variance. Then again, one more circuit was considered, that oscillator circuit. Here again, one noise source was considered. Again, that was analyzed. This is the mathematical thing behind this. Now this is prediction, next part of this. After getting mean and variation, expected value of that, we should be able to predict. What is prediction and what is estimation? What is estimation? What is prediction? Have you heard this word? Prediction algorithm, estimation. What is this?
On the base of estimation, you can predict something.
Something. And where it is required? When it is
Not
correct, up to the mark or with the noisy something, isn't it? We are getting closed form solution, we are estimating something, we are predicting something. So prediction, suppose we have to send satellite, our ISRO is doing great in that. Okay, so whether our satellite will follow the trajectory which was programmed, and whether it is following, when we will get at the time of actual launching, whether our satellite is following the trajectory or not, isn't it? So always you see when ISRO is launching some satellites, there is one trajectory and another is the real time. One is the estimated one or the predicted one, and one is actual one. Small variation is there. Now, if you don't consider these obstacles in the path of that satellite trajectory, what will happen? If you consider all things are very good in space, there is nothing, no obstacle is there, obstacles are there, what will happen?
do not follow the trajectory.
Isn't it? Because many things are garbage in space. Many satellites are there, many things are rotating around or they are in space. If our trajectory is there, suppose satellite is that machine is moving and some garbage comes and strikes that, what will happen? It will change the direction, isn't it? And it will not reach in that. Many times we have been failed. If you check ISRO's history, it is not, nowadays we are launching 100 satellites at a time, but that was not case previously. So we got that accuracy. So all other countries are giving satellites to launch to India. Now we will be satellite launching hub. Many times you will see nano satellites and all that. But important is what? Our accuracy is more. And K.R. Parthasarathi sir was from Tanjore, no? Tanjore, south. So,
Indian Stochastic.
ISI Delhi, he used to work there. So, mathematics is there behind that. It is, we are getting, when program, you will do programming. Software people will come, they will do programming. But what will be the programming base?
Mathematical equation.
There should be some mathematics, some values, some equations. Then only the program will get executed as per that. And if we do not, suppose that two-body problem, I have not taken, but it is famous.
I have
You have explained that? Okay. Two-body problem. Satellites rotating around
Next
the
lecture
Earth.
by Ravi sir.
And if something comes in that path, what will happen? It will change, and for that moment, we will get disturbed signal or it will get disconnected for that moment. And if it is big impact,
then it will not come in scene now after that. So many problems are there. And on the basis of that, in France, that Jackie Cresson is doing research on that two vertebra, and he has named his theorem as a
Sharma
Sharma Patil.
discovery. Means he has taken base of our Sear's theorem, and they are doing research on that, and he has named that theorem by our guides. So they are believing that mathematics is correct and they are applying that. Again, this is, as you said correctly, prediction of will come for. Again here, Kolmogorov comes in picture. Famous equation you. This word is very different. I left this teaching, research, and that after SU90, we are very much missing that research, because that is what, if we are getting this step, we were in that loop that tomorrow we will get this application, next circuit, next results, and they were getting published in good reputed journals. That was our satisfaction. To get PhD is very easy nowadays. Maximum you are PhD or doing masters. So you may find variety of options available in private universities, distance. But if you go in IIT, NIT, still some good guides are there. I am not saying all, but many good guides are there. They are always asking for results. Do something other than what conventions are doing. Then one or two papers in good journals, reputed journals, are sufficient on your name. There should not be a number 100 and 200 or 2000. I have seen, I think our campus, one professor was with the target that per month some 10 or 15 publications were there on his name, and our sirs was only one or two in a year, but reputed. So to have that publication, to have good publication, that matters. So next is, after getting that values, again we have to predict, estimate, and all. Focal classification you might have heard from him. Again, same non-linear sampling was extended, because once you got some result, you can do further analysis on the same after getting the results. Here we have given input colored noise instead of white noise, colored noise. What is the difference? Because in research, what is happening? If you get one, then you do small change in one pattern, then write an article, then do the second one. That variation is also research, and in that you are getting good results. So these are the results with the same value we have considered sampling also. So this presentation has that conclusion which we have discussed. Still this controversy is going on. I think you have written that Ito met Sir's paper was there.
Balaji sir.
They have written that still that controversy is there, which is who is better, Ito or Stratton. Instead of focusing on their results, we are in that process, who is better or which is good. That is correct, because we have to keep faith in one and then in that direction. Otherwise, you will be in dilemma. Same dilemma is there with Ito and Stratton also.
Where to use Ito and where
The
to
method of this talk, where best, and here where to use Ito and where to use Stratton, that is important. The applications of this talk, if you are going in control system, dynamics, or mechanics is also, quantum mechanics is important. Quantum is coming everywhere, you see, in that segment also it is useful.
These are the references.
Nowadays they are working on quantum
Stochastic theory. That is the latest topic.
Quantum.
Those are interested to do, they can have a good future in that. And it is not so that after PhD, one of our that what is the name of that? He joined after PhD to Bangalore. Prashant.
Hmm.
He joined company also related to that. So it is not so only you will be in technical field or teaching field. You might go in the research part of that industry segment also. These are the publications, Journal of Ranking Institute that I have with the guidance of sir. No questions if you are having. Or
May I ask, because I have given some papers, if you have any doubt, you can discuss with sir.
anytime.
He is
I have
great
skip
source.
mathematics because again that derivation with chalk will be very good because it is now printed. And when you are having some while writing this, some things are coming. Problems or mathematics should be always on blackboard. You will take and it will lose your.
You get some clue about your take.
Anything you can
take
ask.
Sir, a small doubt. When we consider adding a noise, so at a time, is it desirable to take, to add one or more, minimum? Is it desirable? With two at least needed? Or else we have, we can keep with the one variable and do the mathematical modeling.
Practically, when you have to draw some conclusion, so that we confirm that in reality or practical, we have to choose. Suppose we consider this AC is having disturbances due to three factors. Just for example, then once mathematical model of this air conditioning circuit or air conditioning system is there, we have to consider these three factors and keep two constant, add one noise in one. Then keep other two constant, add one. So three different equations you will get, three different variations you will get, graphs you will get, and you will come to conclusion out of these three, this second one is having more impact on the output. Then you can suggest manufacturer of this that will please take care of this part, hardware part, related to that second, which will minimize the errors. That is the condition. And before giving some conclusion, you can simulate that in MATLAB or softwares. So that will help to design good air conditioner, good your any amplifier systems, PC, any where noise is everywhere. This is again I am saying randomness is everywhere. I think that in helicopter dynamics, I have done that in my UG college. I have tried to have some disturbances. You know helicopter, quadcopter. So there are blades and that. And you have heard many accidents are there because of helicopter. Mother House India, then Andhra Chief Minister, their helicopter crashed. If all things were correct and helicopter was stable, why that get crashed? Isn't it? So some atmospheric changes were there. If you check all south side accidents was in hilly region and in rainy season or in foggy environment or that. So what is happening in conventional system where all things are okay, but if some disturbance is coming around that helicopter blades, might be density will be more or fog will be more or wind speed will be more, many parameters are there. Those will contribute. Those will contribute. And what will happen due to that? The stability of that particular system will get disturbed. Any turbulence will come. Wind turbulence, atmospheric turbulence, any. So I tried in my lab with the small helicopter, toy helicopter, with the compressor air, and closed environment was there, and I used some sensors
to check some data because one of the paper was there on helicopter dynamics also. So we tried to correlate that. So how due to wind speed change or wind speed which is flowing and it is disturbing the dynamics of that particular blades, how the output will come. That time the helicopter pilot will have only some minimum things to control. They cannot go in algorithm and they can change the parameter like that. Instead of that, while designing such helicopter control system, they should take care that this kind of disturbances may come and that may cause big accidents. Isn't it? So this is real, it is, I am talking in 2-3 lines, it is very easy. But when you are solving problems, it is very difficult. We have to take care of each and everything separately and then we have to follow. Anything? Hope so I am not bored.
Yes, no,
Huh?
from my side.
Hope so that I will be able to give you your answer.
You will be able to. Actually, mostly we are using Gaussian white noise for
Yes.
testing a system because Gaussian is like
Simplest one for our
simplest one
case and it is
natural distribution.
natural distribution.
So how would we compare that with the colored noise? Because very few in for the signal processing fraternity use colored noise in testing.
Basically, what is difference between colored and this is where consume only one. Now, colored noise process in one paper only I have tried. That was I think you were in Balaji. Colored noise was more discussed. I was using maximum white noise only. For one paper only I used that because that is again separate topic. But when you are having just like I will give an example difference between when white ray is passed and spectrum comes. Same thing happens with the noise also. When that all colors, 7 colors, or variation is there, we can have more correct prediction of this estimation. That is my thought. Maybe after going in details, we can draw a conclusion.
White noise is the time invariant system,
And in this,
and colored noise is the time variant.
that is basic. But how it will get impact on that output? That is your question.
Yeah.
So again, mathematics comes. But white noise analysis versus colored noise analysis will be more better, or as per my things, because it takes care of all wavelengths, all segments. This is also one of the topic. You can write paper on that. One paper in that I have just
Because once
done
we-
the
We can
variation.
analyze one
Our
system by
signals like we are going we keep-
both noise.
Yeah, keep on adding
You can consider first
40
white
dB,
noise, then
30
color.
dB, 20
Ah.
dB, 20 dB becomes very noisy kind of signal.
Noisy.
Change lots of parameters. So that's the reason.
Yes, we can consider. And what means when I was teaching DSP in my UG, I used to do that filtering, high pass, low pass, all on MATLAB. One day I was wondering that nothing is passed and we are getting output on paper only, on graphs only. And still we are saying it is filtered noisy signal, it is high pass, high signals are passed, low signals are passed, low frequency signals are passed. And students were asking, so where it is passing? Show us on the lab. Now DSP, you know, digital signal processing at that time, everything was in mathematics very difficult. If you check previous syllabuses of all universities around 95 to 2000, I took guidance of one IIT professor who was working on TMS 320 C50. That time Texas Instruments processor was there. And I designed one small program for low pass filter with assembly language. There was cross compiler, C language to assembly, our machine. Then I passed that particular for frequency generator
above that cutoff, it was getting attenuated. Then I got, okay, this is the result. How the filtering comes. Otherwise, we were in how to show to students that this is filtering. On paper, you can write all this high pass, low pass, everything. We can teach them. But when practically, so that was not my first practical experience that this is low pass, above this it will get attenuated, and on actual processor, such kind of things will have more impact in our teaching learning process. And then instead of showing 1,000 things, do one thing and focus on that, that gives the more better results.
Sir, you have taken randomness in source. So what type of randomness you have included? That means frequency or magnitude?
Hold magnet.
Only
Magnet. Because I have considered battery or any source. Battery maximally, suppose car or any system, battery is there. Battery's output is also getting changed. If you check with multimeter and some temperature variation around the battery is there or vibrations are there, that may contribute the variation. And that one of the things I have taken in source, that you check voltage difference is there. So in voltage parameter I have added that mass. That is mass. Again, that is again one more topic, that what will happen if it is.
So that magnitude is variable or constant?
We have taken that is random. Na? Once the random parameter will get added in the main, that will get converted into random parameter. So that is variable. Undeterministic. Deterministic means we can write some mathematical formula for that or equation for that. You cannot write. So same, if I draw something here, if you take this, x is function of time t, then I can write here x is function of time t with some amplitude, and it is function of sine of t, isn't it? Some amplitude will be there, a, then I can write this equation. But if I draw, can I write something mathematically for this? Is it? So it is deterministic. You can write or you can express this in mathematics, and then you can write some equation or something. But if it is noise around and around, you cannot write something or write mathematical for this. Then what we are doing? We are taking piece of this, we are taking piece of this or this, and then we are applying our methods to solve that through Brownian motion based Brownian process, and then we are getting some closed form solution. Here we are considering the standard ones. If it is RAM, if it is step signal, anything. Anything more? Anything? All of you are from, how many are from this?
Gujarat
JTU.
government institutes
Okay.
as well as private.
Great. So, in government also you are having much time.
તમારે કઈ પૂછવું હોય તો પેલું ન્યૂ રિસર્ચ ડાયરેક્ટર વિશે આમાં તમારે કઈ વિચારવું હોય તો એનડીપી પર તમારે લખવું પડશે ને એવું કંઈ પૂછવું હોય તો પૂછી લેજો.
I will give my background. I have done my BA and
તો
MA
તમને
from
ઈઝી પડે એમ તમને ડાઉટ હોય તો.
Pune University and PhD from NIT. We were together. And from last 15 to 16 years, I was a good teacher. Means I am thinking so. I have my students all over this world. From instrumentation automation background. My passion is to do some good project. Always I am trying to apply some theory in practice with the help of these projects. I have done, he mentioned some projects because the solution was there, but with high this range of money. So we have tried to get that in a low cost. Low cost solution is required in
come to your doorstep, and then they will check stability and all that things. So we tried many projects, and also I have done some, as I was handling some administration. Medical college was there under me, then agriculture college was there, AICTE was there, pharmacy was there. I was trying to integrate all together, because in India, if you are a civil engineer, you cannot do research in computer, or you cannot do post PG in computers. But in abroad, any stream can have, or even students have flexibility to choose one subject from electrical, one from computer, one from instrumentation or lab. But ours is that defined system. You should, electrical means you should go with this lane only. You don't look in computers. You don't look in some machines. Nowadays, due to new education policy, days are changing, but still it will take time to get implemented. IITs are adapting and NITs are adapting. Our private universities are also bound to follow that in it is. But if we do some interdisciplinary research, then good results may come. We are thinking from only one angle, but if it is having application in agriculture, medical, many biomedical instruments are there in abroad. Now here, I don't know, in JTU, biomedical engineering is there, subject is
Some college.
in Maharashtra also same thing is there. No one is taking admission to biomedical. And if you take Texas University, top branch is biomedical. It is not so that that branch is not having weightage, but we are always looking from the angle package, and everyone is going IT and computer. Now today, what is the scenario? All of you know, the place the students are also not getting joining date. The days will change again. For 6, 7 years it will be there. Again it will go up. The sine wave will be there, but still we should do some interdisciplinary research. That is my suggestion. I used to teach signal system, digital control, automatic control system, then robotics and automation was my area of interest. I am now looking for private university and some school project along with the pharmacy coordination in administration.